Hey everyone, happy Thursday. I'm in a new location. I'm recording this from my dining room, so I decided to leave the camera off today. But I hope you all have had a great last couple days. For our lesson today, I was looking back at the lesson check from yesterday, and it seems like some of us could use some extra help on solving systems by elimination. This is going to be a big skill for our next topic. So that's why I want to take a day today, and we're just going to work on solving systems. Okay, so today's lesson is going to have three questions we'll go through together, and then your lesson check also has three examples to do on your own. Okay, so before I get to the one from yesterday, I want to review just how we solve by elimination using this example here. Okay, so it's 2x plus 3y equals 4, and x plus 2y equals 1. Just kind of to go over this, what we want to do is we're trying to find one ordered pair or one point that makes both equations true. So you think back to, what does it mean to make an equation true? Well, if I want to find an x and a y value, let's take the top example alone, or the top equation. I want to find an x and a y value that'll make this statement true. So I want to find an x and a y value that will give me 4 on the left-hand side of the equation. Okay, and then I also want to find an x and y value that'll give me 1 on the left-hand side of my bottom equation. So I'm trying to find the x and the y value that'll be the same that can make both equations true. Okay, to do that, we have three different methods. We could graph both equations. So you could either, convert them both into slope-intercept form and see where the two equations intersect. You could solve them by substitution. Okay, so that's where you have one equation where one of the variables by itself. Maybe this bottom equation said x equals negative 2y plus 1. And then you took that expression and plugged it into the top equation. The other method is elimination, and that's the one that we're going to be using. So the way elimination works is we want to add these two equations together, okay? And when we add them together, we want one of the variables to cancel out. So you think about this right now, guys. If I was to take these two equations and try to add them together as they are, okay? So I was going to add them, so 2x plus x would give me 3x. 3y plus 2y would give me 5y. It's kind of like combine like terms, and then do the same thing on the right-hand side. 4 plus 1 is 5. You see, the problem here is that neither variable cancel out at this point. So what we're going to do instead is we want to take either one or both equations and multiply them by a constant or multiply them by a number so that when I add them together, I'll get one of them to cancel out. So what I mean by that is if I erase this out of here, let's see. Okay. And if we had a negative 2x on this first term here, 2x plus negative 2x or 2x minus 2x would give me 0. So that's what we want to have. So we can do that by taking each term in this bottom equation and multiplying everything by negative 2. Okay, the thing to remember, guys, is that we can't just multiply one term by a number. It has to be every term in that equation. Okay? And the other thing I could have worked too is I could have multiplied both equations by a number. If I could get these two, the y's to cancel out, I would need a positive 6y and a negative 6y. But my whole thing is, if I can do a question out by only multiplying one of the equations by a number, that's what usually I want to do. Next, let's go ahead and do this. So since I'm not changing the top equation, that one's going to stay as 2x plus 3y equals 4. Okay. My bottom equation now, when I distribute this negative 2, so negative 2 times x is negative 2x. Okay. Negative 2 times 2y would give me negative 4y. Now, on the right-hand side, 1 times negative 2 is negative 2. Okay, so we're going to multiply that equation through by a constant. Because now watch what happens. I'm going to go ahead now and add these equations together. So now 2x minus 2x would be 0x, and 0 times anything is 0. So that cancels out. That becomes eliminated. Now my y's, 3y minus 4y would give me negative 1y, or just negative y. Okay? And then 4 times negative 2, or sorry, 4 minus 2 would give me 2. Okay? Now last step. I'm going to get y by itself. So I can multiply or divide both sides by a -1. So y is going to be -2. Okay. Now, we can't just stop when we find the value of one variable. Now we're going to take this y equals -2, and we're going to plug it back into either original equation. So I'm going to take this y equals -2 here, and I'm going to plug it in for y in my bottom equation. So that bottom equation will become x to be here. Remember, ignore the 2's right now. So it'll be x plus that 2 times y. Well, we just figure out y is -2, and that's going to equal 1. Okay, we're going to simplify now. So x, 2 times -2 is -4 equals 1. We're going to add 4 to both sides and get x equals 5. So our solution should be 5, comma, -2. And the key is you always want to write your answer at the end as an ordered pair. Okay. All right, so the one from yesterday. Okay, so we have 3x plus 2y equals 1, and 4x plus 3y equals -2. All right, so now this is a cool one where I have 3x and 4x. All right, those won't eliminate just yet. 2y and 3y, those won't eliminate either. This is an example where we have to multiply both equations by a number. Okay, now you could have chosen to eliminate either variable. It doesn't matter. When I did it out, I chose to eliminate my x variable. I'm going to do that by getting my top equation. This x is going to have a coefficient of 12. The bottom one's being -12. So we're going to do that by multiplying the top equation. I multiplied it by 4. Okay, both sides of it by 4. And my bottom equation, we're going to multiply. I want it to be a negative, so -3. Because we need one to be a positive 12, one to be a -12. Okay, now we're going to multiply through. So I'm going to do 4 times 3x and 4 times 2y. So we're going to get 12x plus 8y. That's going to equal 4 times 1, which is 4. Okay, my bottom equation, we're going to distribute the -3. So I would get -12x minus 9y. That's going to equal positive 6. Okay, now let's go ahead and add the equations together. So 12x minus 12x is 0. That cancels out. Y minus 9, or 8y minus 9y is just -1y, or -y. And then 4 plus 6 is 10, which means y is going to equal -10. Okay, let's go ahead and plug that into either original equation. I chose the top equation here. So now my top equation will be 3x plus 2y. Oh, but we just figured out y is actually -10. And that's going to equal 1. Okay, so then 3x minus 20 is going to equal 1. I'm going to add 20 to both sides. So 3x equals 21. Divide both sides by 3, and x equals 7. So that means our solution is going to be 7, comma, -10. Okay. All right, next one, guys. Go ahead and pause this video and try this example on your own for right now. All right, so if you do this correctly, you should get a solution of 6, comma 4. Okay. So what I did, guys, is I want to show you how you could solve this one, eliminating either variable. So I'm going to start. The first one I'm going to show you is by eliminating my y variable. Okay, this is probably maybe not the way you would want to solve it, because my x's would cancel out pretty easily if I just multiply my bottom equation through by -4, because I had 4x minus 4x, so I don't have to change one equation. But just to show you both ways, I'm going to show you by eliminating y's first. So I'm looking at this and I say, all right, what's the smallest number that both this 3 and the 2 could multiply to? Well, 6. So I want my top equation, I want that to be a -6y, my bottom equation to be a +6y. So we're going to go ahead and we're going to multiply through. the top equation, I'm going to multiply by positive 2. And my bottom equation, we're going to multiply it through by a positive 3. Now again, the reason why I want to multiply them through or both be by positives is because I already have a negative coefficient term and a positive one. So I don't want to change these signs. Okay, so then when I multiply through, I get 8x minus 6y equals 24, and 3x plus 6y equals 42. Okay, we're going to go ahead and add two equations together. So 8x plus 3x is 11x. Negative 6y plus 6y is 0. Those cancel out. And that's going to equal 24 plus 42 is 66. Divide both sides by 11, and x is going to equal 6. Okay, I'm going to go ahead and plug that back into either original equation. I think I chose the bottom one. Okay, I'm going to plug it in for right here. So I could say 6 plus 2y is going to equal 14. Okay, subtract 6 from both sides. So 2y is going to equal 8, which means y is going to equal 4. So my solution is the point 6 comma 4. All right. So now if you eliminate x's, I'll show you that one now. So let's go ahead and solve this by eliminating my x term. So for that, all we got to do is multiply the bottom equation through by negative 4. So my top equation is going to stay the same. It's going to stay as 4x minus 3y equals 12. My bottom equation then will become negative 4x minus 8y equals negative 56. Okay. I add the equations together. So then 4x minus 4x cancels out, that's 0. Negative 3y minus 8y is negative 11y. And 12 minus 56 is negative 44. Divide both sides by negative 11, and y is going to equal 4. Okay, let's go ahead and plug that into either original equation. I picked the bottom one again. So then x plus 2y, but y equals 4, equals 14. So x plus 8 equals 14. So x is going to equal 6. So our solution is 6 comma 4. All right. So guys, that's kind of just what your review is for today. Okay, we'll do more with this in our lesson on Monday. So go ahead now and please work on the Google form. Let me know if you have any questions. But if not, guys, have an awesome, awesome weekend. Take care.